This week we will be doing a skill overview from Unit 8. So our two focuses this week will be I can calculate area, perimeter, and volume, as well as I can classify and identify both 2 and 3D figures. Unit 8 has a lot of vocabulary, so please make sure you study the Quizlet and you look it over. And if you don't know exactly what a term means, if you're doing an assignment, please go back and look at the vocabulary on the Quizlet. So first, we will be starting with area and perimeter, which are a bit of a review. So let me just make sure that this is clear. All right. So we're practicing with area and perimeter. So first, we should go over the formulas. Perimeter is equal to 2 times the length plus 2 times the width, or adding up length plus width, or adding up all the sides. Perimeter is the distance around, so you're adding up all of the sides. Area is how much the total shape covers. So area is the inside, the space inside, and area is equal to length times width. So let's do some of these first. So the perimeter of this shape here, okay, it says that, so it says the length or the width, whatever you want to call this, is 1/2 centimeter, and this is 1/2 centimeter. This looks like a perfect square, so all of these are going to be 1/2. I can label them if I would like to. I'm going to label them just for us to look at. So for the perimeter, we have to add up all of the sides, or we do 2 times 1/2 plus 2 times 1/2. I'm going to add up the sides because I'm going to use grouping in order to do this in my head. 1/2 plus 1/2 is 1 whole. 1/2 plus 1/2 is 1 whole. 1 plus 1 is 2. So our perimeter is 2 centimeters. So it is 2 centimeters all the way around. Next, for our area. Area is equal to length times width, and you square your area. So your centimeters will be centimeters squared because it's covering the square of the surface. So we need to do length times width. That would be 1/2 times 1/2. Now we solve. 1 times 1 is 1. 2 times 2 is 4. So our area is 1/4 centimeters squared. Let's move on to, we're going to go down to number 9. You can pause and try to solve for the area and the perimeter on your own and then check your work. So 4 inches, 5 inches, that's what we have labeled. This side and this side are congruent or equal. This side and this side are congruent or equal. I marked these two sides with 1 line to show that these are the same, and I marked these two sides with 2 lines to show these are the same. So I'm going to bring my 5 inches over here and my 4 inches over here, just so I know what all of my sides are. And now to solve for perimeter, we're going to add up all of our sides. 4 plus 5 plus 4 plus 5. I'm going to use another grouping strategy in order to do this. I'm going to do 5 plus 5 first, which is 10. 4 plus 4 is 8. 10 plus 8 is 18. So the perimeter, or the distance around, is 18 inches. Now we solve for area. Area equals length times width, 4 times 5. So our area equals 20, and we always square our area, so it's 20 inches squared. So that means that this amount in here is 20 inches squared. Okay? So that is how you solve for perimeter and area. Again, perimeter is adding up all the sides. Area is multiplying the length times the width. If you were to work backwards, like we've done before, so if it gives you the area, we know that area equals length times width, but it's given you the area. So it's telling you the area is 29.76 meters squared, or square meters. You could see it written both ways. Equals length times width, so we have one of these. We have 4.8. We do not have the other one. So now we need to use the inverse operation in order to solve. So to solve for one of the sides, when you have the area, you take the area, you divide it by the one value, and then that will give you the other value. Okay, moving forward to volume. So volume is our third way of determining the size of an object. So the perimeter is the distance around. The area is how much surface it covers up, so how much of this table, this book is covering up. And volume is how much total space it's taking up. So this book is sticking up into the air. So it would take into account how much airspace this is taking up as well. So here we have, it's having us find our length, our width, and our height, because the formula to calculate for volume is V equals length times width times height. Okay, that is the formula for volume. So here it gave us the length, the width, and the height. The length is across, the width is how deep, and the height is how tall. And then you multiply these three numbers. The reason these first two are in parentheses is it just wants you to go from left to right, just like how we read. So 7 times 4 is 28. 28 times 5 is 140. We squarea our area. We cube our volume. So it is 140 cubic feet, which could also be written as feet with a 3 after it. Cubic feet. Because if you think about a cube is three-dimensional. So it sticks up into the air. You can only calculate the volume of something if it is three-dimensional. Three-dimensional means it has a height. So here is a two-dimensional figure. You can't pick it up. It has a length and a width. Here is how you draw a three-dimensional figure. Bear with me, I'm not the best drawer. That would be a three-dimensional figure because it has a length, a width, and a height. So let's do number 8 together. So it's 6 centimeters in length, 15 centimeters in width, 10 centimeters in height. See if you can calculate the volume doing length times width times height. You can pause and do that. So our length is 6 centimeters. Our width is 15 centimeters. And our height is 10 centimeters. Now we're going to write our formula. So it's 6 times 15 times 10. You multiply those three numbers, and then you write your answer either as cubic feet or feet cubed. So if you want to, because this is multiplication and because of the commutative property, you can switch around the order. But if you're doing it from left to right, that follows PEMDAS lovely. So you do 6 times 15 and you get 90. Then when you do 90 times 10, you're making it 10 times bigger. So the volume is 900 cubic feet. So again, the formula for volume is length times width times height. Now we're going to move into understanding two-dimensional and three-dimensional shapes and learning how to classify both quadrilaterals. Quad means four, so four-sided figures, as well as triangles. Tri means three, so three-sided figures. So I find that this table in the teacher edition of the book is very helpful. So it goes through what a parallelogram is. The base word is parallel. A parallelogram means the opposite sides are parallel. So the opposite sides will never touch, even if you continue them. So these two sides of the table are parallel. So the opposite sides are parallel. the opposite sides are congruent. Congruent means equal. This side and this side are the same length, so these are congruent. Opposite angles are congruent. So that means that these two angles are the same, which they are, and these two angles are the same. That's a parallelogram. A rectangle has opposite sides that are parallel, opposite sides that are congruent or equal, and 4 right angles. This is a rectangle. It's also a parallelogram. So a rectangle is a parallelogram. A rectangle is a parallelogram. But a parallelogram is not a rectangle because the rectangle has to have 4 right angles. So a rectangle is a parallelogram. Next we have a square. A square has opposite sides that are parallel, 4 right angles, right means 90 degrees or a perfect L, and all of the sides are equal. So this is not a square because the opposite sides are congruent, but all the sides are not. You probably know what a square is. A rhombus, that's how you say this word, rhombus. A rhombus has opposite sides that are parallel, and all of the sides are congruent. So opposite sides will never touch, and all the sides are the same length. So a rectangle is a parallelogram, just like a square is a rhombus. So a rectangle is a parallelogram, just like a square is a rhombus. You can't go the other way because a square has to have 4 right angles. A rhombus does not. Lastly, we have a trapezoid that has 1 pair of parallel sides. So that means only 1 pair of the sides will never touch. The other ones might eventually. All of these figures, a parallelogram, a rectangle, a square, a rhombus, and a trapezoid, can be drawn many different ways as long as they have these attributes. Okay? I find this to be helpful. So if you want to pause that and refer back to it for your homework, that would be great. All right. Now, moving forward, let me turn this on. So we are going to look at these statements about quadrilaterals. Quadrilaterals have 4 sides, and the sides have to be line segments. So they have to be straight. Okay? So we're going to read the description, and we are going to say whether it is true or false. True, it is a quadrilateral, or false, it is not a quadrilateral. So it says, if the statement is false, sketch a counter example. Counter means opposite, so sketch the reason that it's wrong. All quadrilaterals have at least 1 pair of parallel sides. Well, that's false because this is a quadrilateral. It has 1, 2, 3, 4 sides, but it doesn't have any pair of parallel sides. If these continued, they'd cross. If these continued, they'd cross. If this continued, it would cross. If this continued, it would cross. So this is false. A quadrilateral doesn't have to have parallel sides. Just like how this is a quadrilateral. All of these sides would eventually cross, or are already crossing. So that's false. Let's move on to number 2. All squares have at least 1 pair of perpendicular sides. Well, that's true because I know my square isn't perfect, but these sides are perpendicular because they cross. Moving on. A rhombus must have an acute angle. Acute means smaller than that 90-degree L. So like this is an acute angle. If we refer back to the chart before, a rhombus has to have opposite sides parallel and all sides congruent. So it doesn't have to have an acute angle because this is a rhombus. If you look at this rhombus, the dashes through the sides show that all of those sides are congruent. So all of these sides are the same, which is what it needs. The second attribute is that the opposite sides are parallel. This side will never touch this side, and then the opposite ones, these sides will never touch. So this is a rhombus. Just to go over the way that you label a shape, these lines show congruency. So since they're all the same, I put one line on them. These squares in the corners mean right angles. Okay? So that is a way that you can reason and sketch quadrilaterals. There's lots of rules for it. It can seem confusing, but just use the chart that I showed you before. So rewind to that and use that if you need to. Okay? Don't make it harder on yourself. Moving forward. So as you can see, I wanted to show you this as a demonstration. All of these are quadrilaterals. They have four sides. They're closed, so they're not open. They don't have an opening in them. Four sides. They're closed. And they all are made up of straight lines. So this is not a quadrilateral. Because first of all, it only has one side. And this is not a line segment. This is a curve. So that can't work. Same way that this is not a quadrilateral because it's open. It's not closed. So you can see that quadrilaterals can look many different ways. Let's look at quadrilateral I. These two sides are congruent or equal because they both have double dashes. These two lines are congruent or equal because they both have single dashes. And these squares indicate that these angles are right angles or 90 degrees. Okay. The next thing we are going to look at is understanding triangles. So there are two ways to categorize triangles. You can categorize them based on their sides or based on their angles. So if I were to ask you to describe a triangle to me, you could say one of these things and one of these things. So there are two ways to categorize, classify, or describe a triangle. You can describe it using its sides and its angles. So for sides, a scalene triangle has no congruent sides, so none of the sides are the same length. An isosceles triangle has at least two congruent sides. So scalene, none of the sides are the same length. Isosceles, two of the sides are the same length. And an equilateral triangle, equa means equal, means that all three of the sides are congruent or equal. So, you can classify a triangle by its sides looking at the length of the sides. Scalene, none of the sides are the same. Isosceles, two of the sides are the same. Equilateral, all three are the same. So you can't tell me, oh, this triangle is scalene and equilateral. It can't be that. A triangle can be one of these, okay? One of these. It could also be one of these based on its angles. So a right triangle has a right angle. It has that 90-degree L angle, like this, with the box in the corner. So like this is a right triangle. An obtuse triangle has an obtuse angle or an angle larger than a right angle. So it's wider, like this. You see how this angle here is much wider than this angle here? We have the L, and then we have a very wide angle. So your triangle could be right and have one right or 90-degree angle. An obtuse triangle has a one obtuse angle or one bigger angle. And an acute triangle has all angles that are acute or smaller than 90 degrees. So this is an acute triangle because all of these angles are smaller than 90 degrees. They're smaller than the L. So we have acute, right, obtuse. That's usually how I remember it. So your triangle cannot be both a right triangle and an acute triangle. No, it can be one from here and one from here. Okay? So that will help us moving forward. I just need to readjust my document camera. We're going to do the same thing that we did with the quadrilaterals, just with triangles. So it says, all isosceles triangles are also equilateral. Well, that's false because an isosceles triangle means that two of the sides are equal. So these two sides are equal, this one is different. So that statement is false. A scalene triangle cannot have a line of symmetry. That is true. Because scalene triangles all have different sides, you can't evenly split it so one side is equal to the other because all of the sides are different lengths. So a scalene triangle does not have a line of symmetry. All right triangles have two acute angles. That is true because do you know how many degrees are in a triangle? There are 180 degrees in every triangle. Okay? So a circle has 360 degrees inside. A triangle can only have 180. So here's a right triangle. If this one is 90, both of these are some number of degrees, but it can't be over 180. So you can't have 90, 90, and 90 because that would be bigger than 180. You can't say this is 90, and this is 0 because that's not 0. So all right triangles, if they have one 90-degree angle, it means these other ones are going to be smaller because they have to be. Let's do this one here. Last one right here. All equilateral triangles are acute. So an equilateral triangle is a triangle with equal sides. Acute triangles are triangles that have all three angles that are smaller than 90 degrees. That is true. Because if you have to have them the same length, let's pretend these are all the same length and my drawing is perfect. The angles have to be small. Say I wanted to say, okay, I want this to be the same length as this. Okay, I'll say these two lines are the same length. This one is not the same length. It's much longer. There's no way to make a triangle, and this is a right triangle. So an equilateral triangle where all of the sides are equal has to be acute. So all equilateral triangles are acute. Now, it's hard to do these. I'm most concerned with you understanding the tables that I showed you about triangles and the tables that I showed you about quadrilaterals. Those are on the Quizlet. Study the Quizlet. Looking more at shapes, these shapes These are different ways that you can classify shapes. So we have open shapes, closed shapes, polygons. That's what we're going to focus on. We're focusing on up here. So two-dimensional shapes can be open shapes or closed shapes. So this is an open shape because it has this gap right here. This is a closed shape. This is a shape. So these are two-dimensional shapes. You can't pick them up. They don't have a height, but these are shapes. Polygons, a polygon, poly means many, so it's a many-sided, closed two-dimensional shape. It's made from line segments that don't cross. Okay? Let's look at these examples and non-examples. So one more time. Polygon, poly means many. A polygon is a closed, so it can't look like that. It's got to be closed. Two-dimensional shape, so you can't pick it up. Made from line segments, which means straight lines, and the lines cannot cross over each other. So looking here, this is a polygon. It's closed. It's made from line segments, and none of the line segments are crossing. That's a polygon. Same here and here. These are polygons. They're closed, made with straight lines, and they're not crossing. These are not polygons. This is not a polygon because why? The line segments are crossing here. This is not a polygon. Why? Because it's not made out of line segments. And this is not a polygon. Why? Because it's not closed. It has this gap right here. It can't be open. So, two-dimensional shapes can be open or closed. Polygons are a type of two-dimensional shape. A polygon has many sides that are made of straight lines and do not cross, and it is closed in. So that is our geometry work from Unit 8. The final piece from Unit 8 that I need you to practice with are a thing called line plots. Line plots are basically a graph. You just put it on a line or a number line. So the first thing that you do is draw a number line. Now we are going to label it and plot it just like it's a graph. So it's a way of understanding information. For 10 days, Mario measured the amounts of food that his cat Toby ate each day. The amounts he recorded are shown in the table at the right. Graph the results on the line plot. So looking at our table, the title, amount Toby ate each day for 10 days. These are the amounts, and each tally equals 1 day. So for 2 days, he had 1/4 of a cup. 1 day, he ate 3/8 of a cup. For 3 days, he ate 1/2 of a cup. For 3 days, he ate 5/8 of a cup. And for 1 day, he ate 3/4 of a cup. We add all these up. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 1 is 8. 8 plus 2 is 10. So these are the days, or how frequently these amounts were eaten. So the thing that changes is what he's eating each day. These amounts are kind of what he's choosing from. So we're going to plot the amounts. Now, we're just going to plot them in order that they're written here. It doesn't have to be in order from greatest to least. So I'm going to put 1/4 here, then 3/8, then 1/2, 5/8, 3/4. Okay? This is for the title. The title is amount Toby ate each day for 10 days. And then the way that you do a line plot is you then plot dots to represent your data. So how frequently did he have 1/4 of a cup? 2 days. So that's 1, 2 dots. How frequently did he have 3/8 of a cup? Just one of the days. So on and so forth. So 1/2 of a cup, was 3 days. And you want them to kind of be the same size. 5/8 was 3 days. And 3/4 was 1 day. So now you can look at this line plot and answer questions about the data, like how many days did Toby eat half of a cup? 3 days. How many days did Toby eat less than 1/2 of a cup? So how many days did Toby eat less than 1/2 of a cup? Well, 3/8 is less than a half. 1/4 is less than 1/2. So 1, 2, 3 days he ate less than 1/2 of a cup. How many days did he eat more than 1/2 of a cup? Well, 5/8 is more than 1/2 of a cup, and 3/4 is more than 1/2. So he ate more than 1/2 of a cup 1, 2, 3, 4 days. So these are the days, these are the amounts. This is a line plot. It's just another way to show information and read information.